This is Lab 1.3, in which we will read in a CSV file of receivables, add calculated columns, and then save the data as an XLSX file or an Excel file. Now make sure that you've already downloaded the receivables.csv file, which contains our data, as well as the lab0103.py file, which is a Python script file and has these instructions replicated in there. I have already downloaded those files, so I will now open up Spyder. And to open Spyder, I will first launch the Anaconda Navigator by looking in my applications for Anaconda Navigator and double-clicking on it. And then I'll wait for a few seconds until that launches. Once the Anaconda Navigator has launched, I will scroll down until I see Spyder, and I'll click the Launch button, and then wait for Spyder to finish launching. Now that Spyder has finished launching, I will open up the Python script file for this lab by clicking on this open icon in the top left-hand corner of Spyder, and then navigating to where that file is located on my machine. Now here's the file, and it has all the instructions in it. So let's go down to these requirements and work on these. The first requirement is to import functions from the pandas module by running the code import pandas as PD. So I will type out import pandas as PD, and then I can click on this run button up here. And if I hover over it long enough, you can see a shortcut key that says I can run the selection or current line by pressing F9. So I will do that in the future, but I'll go ahead and click that button. And in the console, I did not get an error, which is great. That means it worked. So requirement 1 is done. The second requirement is to read in the receivables.csv file and save it as a data frame df. So we're going to type out df as the new object that we will create, a data frame, and we're going to set it equal to, and then we'll type out pd, meaning we're going to reference functions in the pandas module. Then if I hit a period and then start typing out read, you can see that I have a lot of different options for reading in data, and I'm using the up and down arrow keys to select the different options. Well, since this data is in a CSV file, I'm going to use this read CSV function. So I'll hit enter, and then I can see all the arguments that I could potentially use for this function. Now all I really need to use is the file path. So I'm going to enter the file path in quotation marks. Now it's important that you use the full file path of where this file is located on your machine. Now I could find where this file is located if I go to my Finder on this computer and navigate to where that's at in here. And if I right click on it and hold the Alt key down, I can copy receivables as path name. All right, and then I could come in here and paste it in there. So that's one way of finding, whoops, need to put it in the quotation marks. That's one way of finding the file path. Now I want to show you another way that you can find the file path by staying within Spyder. Up in the top right hand corner where the Variable Explorer lives, there's also this Files pane. And in here we can navigate to files in a very similar way. So I know where this file is located. I'll just go ahead and scroll till I find it. Okay, so here's the receivables.csv file. If I right click on it, I can copy the absolute path, and then I can go ahead and paste it in there. All right, so that's kind of nice. I don't have to leave the Spyder environment. Now when you have a line of code that extends beyond this gray line, that's totally fine. If you want it to look nice, you can use a backslash, then hit return, and then just make sure that you don't have any spaces in there, and then it might be easier to read. I'll highlight that, and then I'll push the F9 key, and I did not get any errors. And also if I go to the Variable Explorer, you can see that I have this data frame object. It has 100 rows and 6 columns in it. If I double click anywhere in that, it opens up this browser window where I can look at this data as if it were in an Excel file and even sort the observations in ascending or descending order. I'll go ahead and close that because that has completed the requirement for number 2. And now we want to create a new column, total, that is equal to the product of the values in the quantity and the price columns. So to do that, we'll type out the data frame name, then we'll use square brackets, and then in quotation marks, I'll type out total. Then I will set that equal to, and now I need to indicate the column names. Now I also need to indicate the data frame name. So I'll type the data frame name and then period, and then type out quantity. And then I will use the asterisk to multiply the quantity values by the price values. Okay, and that's all I need to do there. Then I'll run this line of code by pressing F9. And now you can see that the size increased from 6 up to 7, meaning I have 7 columns in this data frame. And if I double click on it and scroll to the right, you can see I've got this total column in here. Very good, so it looks like it worked. The fourth requirement is to create a new column, item date, that is equal to values in the item column and the value in the invoice date column separated by an underscore. Then it gives me an example there. All right, so this will be pretty similar to what we did for the third requirement, but here we are combining text and date values. It's pretty simple though. So we'll add this new column to our data by typing out the data frame name and typing out the name that has been prescribed, so item date. And we'll set that equal to, and then we want the item column, and then we also want to add to it the value in the invoice date column. So I can do that. I can concatenate text by using just a plus, and I'll type out df.invoice date, and you can see that it's suggesting, hey, I think you want to use that column. So I'll just go ahead and hit enter. But I also want to have an underscore in between these. So I'll move my left arrow key to go back over here, and I'll add another plus, and then in here I want to just type out an underscore in quotation marks. And then that should do it. So let's go ahead and run this. I'll hit F9, and now I can see I've got 8 columns up here, and I'll double click on it. And now I can see if I scroll over to the far right, I've got this item underscore date column, and sure enough, it concatenated the value in the item column with the value in the invoice date column separated by an underscore. Okay, so we've completed requirement 4. The last requirement is to save the data frame as an XLSX file to your downloads folder. And then we'll use this following naming convention. To complete this requirement, we'll use the data frame's name and then the period, and we'll type out 2_excel. We'll talk more about how you can look at all these functions that are available at another time, but it's simply 2excel, and then we need to indicate the file path to where we want to save this data. Now, since we want to save it to our downloads folder, I'm going to go up to the files, and then I can navigate up to a higher level in this hierarchy by clicking this up arrow key. And okay, in here I've got the downloads. So I'll go ahead and right click on downloads, copy absolute path, and come back to df2excel and hit the quotation marks, and then paste that by pressing Command V. And that's just the path, so I also need to add more to that. I'll hit a / and then type out the name here. Okay, so updated receivables underscore ronguymon.slsx. And then go ahead and hit F9. All right, there were no errors, which is great. So that suggests that it worked. But let's go ahead and verify that it worked. I'll go over to my Finder and navigate to my downloads folder. And here's this updated receivables Ron Guymon file. I'll double click on that. All right, so I've got the total in here, the item date, and then I've also got another column in here. This is the index column or the row identifier. We can talk about how to remove that at a later time. So this lab is an example of how you can read, manipulate, and write data. And this concludes Lab 1.3.